So over the last two videos, I've introduced you to the concept of utility AI and also discussed some high-level concepts that are relevant to Athena AI. For this video, we're going to start our deep dive into the technical aspects of Athena AI, starting with considerations. So what are considerations? Well, there's a lot of ways that we can answer this question, but I'm going to start off quite literally. Considerations are just a normalized float. That's it. They're a way for us to take information from our character, normalize it, and then use that normalized data to get information off of a curve. So let's hop over to Unreal Engine and I'll show you what I'm talking about. First, we're going to look at some examples and then we'll loop back to more philosophy. So we're going to look at a Boolean consideration, Athena AI.considerations.isSquadLeader. This one. First and foremost, when I set up the value for this consideration, we use a different node, setConsiderationValue, instead of setConsiderationDefaults. For a Boolean consideration, all we really care about is the value, not really the range of values that it could be. This range of values is applicable only to float considerations, as it impacts normalization. If you hover over this node, though, you'll see that a note pops up that explains that the consideration will be initialized if it hasn't already been, so we're in good shape there. Now, notice that the Boolean value is converted to a float. This is because in C++, Boolean true or false also equates to 0 or 1, and this is exactly the behavior we want to take advantage of here. So in this instance, if isSquadLeader is false, then the consideration will output 0, and if it's true, then the output is 1. You may recall in my last video that when scoring, the output score is the value of all the considerations for a task multiplied together. Well, anything times 0 is 0, so this task will never happen as long as this Boolean is false. This is what makes considerations so powerful. We can completely zero out a task if we aren't careful with our design. For this consideration, I like to assign it to tasks that only my squad leaders can take. Or we could inversely use this to do with tasks that we only want squad members to take, but not squad leaders. You can see here that I use this on my move to objective task. I want my squad members to follow the squad leader, not move to the objective themselves. This is actually kind of a key consideration here, because having too many navigation calls on the nav mesh can lead to performance problems. So this is sort of a backdoor way for me to change the design in my game. There's a few options I could take here, like preset switching, where I have one preset for squad leaders and one preset for squad members. But instead, I ultimately decided that this was a better route. Why? Well, it allows flexibility in my squad system without necessarily consuming more resources. Instead of having to load a whole new data preset and then initialize all the considerations in the event when a squad leader dies, I simply update the bool isSquadLeader, and then that set of tasks will be considered again. Now that we've looked at and thought about a Boolean consideration, let's take a look at another float consideration. For this one, we'll look at my Athena AI.considerations.health consideration. Notice this time we're using the setConsiderationDefaults node. That's because we want to have control over the range of information when normalization occurs. We plug in an initial value, the health of the character, and the max value, max health. We also set a minimum value of 0, as the character will never have health less than 0, at least not that we care about in this instance. That's really all that there is to float considerations. They're a lot easier to wrap your mind around, in my opinion, at least with respect to the considerations themselves. All of the interesting work with float considerations comes in the consideration curve, which I'll cover in a future video. So let's talk briefly about good considerations. To me, there aren't really good or bad considerations, it's just a matter of how we use them. For instance, in my first video I mentioned that using Boolean considerations isn't really a best practice. Well, this is a somewhat fair statement, but it's not totally honest or reflective. There are use cases for them, but you could argue that there's other ways around their effects, as I discussed previously with preset switching versus just resetting the Boolean for a squad leader versus squad member. This sort of gets back into something I mentioned briefly in my last video, learning to think like the AI. In other words, what information do we care about? Well, there's a simple answer here to me. We want as much information as possible without impacting performance, and it's up to you to decide how to use that information. Take my Boolean consideration that I mentioned above. If used incorrectly, that consideration could really mess up my system if I'm not careful, because it's going to zero out a task that I may not want it to. However, used properly, we can design a flexible system that allows for better behavior of the AI, or at least behavior that I want. There's no one-size-fits-all answer to how to select good considerations, so instead I'll just leave you by saying it's not necessarily the information you give the system, but how you use the information you have.